Physical chemistry is a branch of chemistry that focuses on the study of the fundamental principles and physical properties that govern the behavior of matter, the energy changes associated with chemical reactions, and the underlying forces and interactions at the atomic and molecular level. It combines concepts from both physics and chemistry to explain the macroscopic and microscopic behaviors of substances. Some key areas of study within physical chemistry include thermodynamics. Thermodynamics deals with the relationships between heat, work, energy, and the properties of matter. It explains how energy is transferred and transformed during chemical reactions and physical processes. Thermodynamics provides insights into concepts like entropy, enthalpy, and Gibbs free energy, which are crucial for understanding the feasibility and direction of chemical reactions. Kinetics. Kinetics is the study of reaction rates and the factors that influence the speed of chemical reactions. It involves investigating the mechanisms by which reactions occur, the role of catalysts, and the effects of temperature and concentration on reaction rates. Quantum mechanics. Quantum mechanics is the branch of physics that deals with the behavior of particles at the atomic and subatomic levels. In physical chemistry, quantum mechanics is used to describe the electronic structure of atoms and molecules, as well as to predict their spectroscopic properties and reactivity. Statistical mechanics. Statistical mechanics bridges the gap between the behavior of individual particles and the macroscopic properties of matter. It uses statistical methods to describe the average behavior of large numbers of particles, helping to explain concepts like temperature, pressure, and other thermodynamic properties. Electrochemistry. Electrochemistry studies the relationships between chemical reactions and electrical currents. It examines processes like redox reactions, reduction-oxidation, electrolysis, and the behavior of electrodes in various solutions. Electrochemistry has applications in batteries, corrosion prevention, and electroplating. Surface chemistry. Surface chemistry focuses on the interactions that occur at the interface between two phases, such as a solid and a gas or a liquid and a gas. This field is important for understanding phenomena like adsorption, catalysis, and the behavior of colloidal particles.